Hi, my name is Thomas Gaffney. I'm in product management and I'm overseeing the synthetic data generator capability in WatsonX.ai. And what I want to do today is one, share with you what we're doing from a synthetic data standpoint and how we're leveraging alternative models to generate synthetic data for the enterprise. But also, I want to walk you through a few use cases as well as our roadmap. So you have an idea of not only what we can deliver today, but what we expect to deliver toward the end of this year and into early next. Now, what we've been seeing so far is that from synthetic data, but also at its root, just a real data gap problem. It's persistent across industries. We've been speaking to people within finance, telecom, insurance, health, auto, marketing and communications. And we all hear the same thing, right? We need more data. And these little data gaps that are kind of spread throughout each organization are really aggregating into becoming an innovation problem. Companies want to move faster, but they can't move as quickly as they need to, given their efforts, given the pace of the market. And so if you look down below, that's one example of how slow or how quick some of these companies can move. They're investing in AI. AI requires data to train, but they're going to deploy 2% of their models that they're working on. And so this is a real innovation issue, but there's also opportunity there. And if we can take that 2% to 5% to 10%, maybe even to 20%, you know, 40 models. That is significant improvement over what companies can do today. Now, this is partially what's kind of driving some of the issues with the current data today, right? So one, if you try to use real data to address some of these gaps, you're exposed to additional risk in the terms of financial penalties. So there's been 2.3 billion since 2017 related to GDPR and privacy. So that's part of what's kind of preventing companies from accessing their current data to move quicker. Now, let's say if they want to collect the real data, right, rather than use their existing, well, then they have to be confronted with additional costs, right? Spending more and more of their budgets on collecting the data versus potentially alternative solutions. And then, of course, there's also just delays with regard to how quickly they can move. So if they could access the real data, and if there were no privacy concerns, then we're talking about weeks. We've seen up to months of just getting access to that data for that particular use case. Now, by addressing these, in particular with synthetic data, you could begin to circumvent or address or mitigate some of the concerns that are slowing these companies down. So one, in terms of innovation and go-to-market speed, you can generate the data that you need. You don't have to wait for it. You don't have to spend for it. Two, minimal risk. So because it's synthetic data, you're reducing your privacy risk. But two, we're adding additional mechanisms on top of that synthesis process to help clients get more insight and more control over how much privacy protection they're guaranteed with every synthetic job run. Three, reduce cost. You're not spending on collecting data, you're not spending it on financial penalties, but rather on the data that you need. For scale, you generate as much synthetic data as you need for that particular use case. And then five is opening up other opportunities. Data that's valuable but protected and sensitive that couldn't be accessed can now potentially be shared. It could be monetized. And with that comes new insights. With that becomes potentially new revenue streams. And because of these benefits, we're seeing a significant amount of adoption over the next few years. Sometimes Gartner will say 60% by 2024. You'll hear Forrester say, some other number. And while they may differ apples to apples, they do all agree that companies are going to adopt synthetic data, and they're adopting synthetic data because synthetic data is helping them to get around and tackle some of their real data issues. That's causing them to move slower. Now, let's take a quick turn and focus on WatsonX and our particular solution. So, there are two types of synthetic data. You have unstructured synthetic data. This is the text, the images, the video. And you also have tabular synthetic data. This is data with a schema, with rows and columns, with labels. Now, while on WatsonX.ai, you'll be able to tackle unstructured synthetic data, specifically text, by leveraging the large language models. On the synthetic data generator side, with that tool, that will help you tackle some tabular synthetic data use cases. So that's how the two kind of coexist and also how they kind of balance each other. Now, when we think about tabular data, synthetic tabular data use cases, these are the seven that we see and hear most often. And it's pretty common across, regardless of what company you are or what industry you're in. So one is demo data, using synthetic data to create more realistic client-facing demos. Two, AI model training. We saw that second quote, 2 out of 200. They can generate synthetic data for edge cases or to create more sample data from a smaller sample set to better train your AI models. Three, creating realistic employee training materials, right? Rather than it's creating kind of more realistic scenarios to improve the quality of the training that you give internally. Four is taking a copy of your private data and either sharing externally to business partners so that you can align and coordinate and get better insights, or it's monetizing that data set. So think about if you're a financial company with a lot of transaction data, years and years of transaction data. They're very valuable to a lot of companies out there. You could potentially monetize that with little concern for privacy and while ensuring that you still have the quality there. Five, extract insights. Again, you're taking a synthetic replica of your private data, but now you're keeping it internally. This is for your product teams, for your corporate strategy teams, extracting insights from that data set. Six are what if assessments. So these are, white space, new cases where you don't have data, where you may want to simulate new events so that you can understand what the dynamics may be at play there. So you can create a simulation. For example, if you're in the financial sector, maybe it's, simulating transactions over, 1 million customers and seeing how many of those are fraudulent or not. So you create a simulation, you add in business rules, and then you run it. And then you assess kind of high-level KPIs. And then the last one is synthetic test data. And this is also a very common use case where you require kind of high-fidelity multi-table synthesis. Very common from the market in terms of what the synthetic data needs are. Now, we don't tackle all these yet, but this is in our vision, and we can tackle some of these now. And for each of these, you can't leverage the same model. So we're introducing a variety of models to help tackle some of these use cases. So one is a statistics-based model. The second is an agent-based model. And the third is a generative AI model. Now with the stats-based, it's quick, it's affordable. It gives you CPU versus GPU, so there's no infrastructure restraints. And also gives you a bit more control over whether you can adjust a source schema or not. Now that being said, you do need to understand data distributions if you want to adjust source schema, and it's not as line of business friendly. And because it's quick, because it's efficient, it's really suited toward use cases where you don't need a very high fidelity. While this is designed to reflect your source data, it's a lower fidelity relative to, let's say, a Gen AI model. Now with the agent-based model, this is one where it begins to incorporate simulations. So if you do want to handle that what if use case, the agent-based model is probably your best bet because it allows you that flexibility to create a new simulation that perhaps you haven't collected data for, and then apply some domain expertise in the form of business rules to help model how those agents interact under certain conditions. Now, you do need some domain expertise. This is a rather complex use case. It's not the one that companies often go to. Rather, it's a capability that companies already mature with synthetic data, already familiar with synthetic data and comfortable with it. They may leverage an agent-based model to add in their tool to their toolkit, if you will. And then finally, we have the generative AI model. Now, what's great about this model, it's one, it's low upfront effort. It's very high fidelity, so great at capturing complex relationships in your original data set. And naturally, it's more line of business friendly. Now, with that said, it takes a little bit longer. It's still quick, but a bit longer than stats based. And but two, you do get a much higher fidelity with the Gen AI model, given the AI model that's modeling it. And it does require GPU versus CPU, but it's a pretty common GPU. It's not um, as difficult to find. Now, for my previous comment, not all these models can address all these use cases. So what I've done here is I've given you kind of a cheat sheet, a mapping, to show you that if you were interested in one use case over the other, which model would be better positioned. So for those first three that I mentioned, demo data, training data, and even some AI model training, you can definitely use a stats-based model. You try and generate edge cases, realistic demo data. It doesn't really require high fidelity. Then a stats-based model is definitely an alternative or a possibility for you. For use cases 4 and 5, you'll definitely want to look at a Gen AI model, given the higher fidelity that they're going to provide you with. And actually, I'll say that's true for 4, 5, and 7, which you'll see in the bottom row. Uh, you'll have some of that multi-table synthesis that we anticipate. You'll have the high fidelity. And so those types of models will be better suited. And then, of course, the what if we've alluded to already is going to be that agent-based model. So if you did want to explore kind of white space, new scenarios, a simulation approach to generating synthetic data could be a good fit. Now, in terms of schema, you see that they can all ingest existing data. If you did want to create a custom data schema, which we do see, it's not uncommon. We often see businesses expressing interest in both approaches. You can definitely use our statistics-based model to do so. And then finally, with regard to the data types that we support, these models support categorical and continuous. We do have plans to support time series and special types, but we don't expect that probably for the next 6 to 8 months. Um, Now, this is another important topic that we hear, which is, all right, Tom, I hear you. All right, IBM, you can generate synthetic data. We can leverage these different models. We can tackle these different use cases. But what's our privacy risk, right? If we're leveraging synthetic data that still uses existing data, there must be some risk in there. Now, we mitigate that risk with our approach to privacy, which is leveraging differential privacy. Now, what differential privacy allows, or what it gives the user, is one, control over how much privacy they need in their synthetic output, but two, guarantees into how much privacy they're afforded. And then three, computational transparency, which you see in the bottom right. With traditional demasking techniques or randomizing, you don't have that computational transparency without exposing some risk. But with differential privacy, you actually understand what's going on and how the privacy is being guaranteed and provided. And then fourth, what a differential privacy approach um, helps users to do is that one, it guarantees that no that a third party attacker can't identify data specific to an individual. So no personally identifiable information specific to any individual is leaked or can be traced back within a synthetic output. The way that works is because differential privacy adds noise to any area of your data set that may be vulnerable to third party attack. And what it means by adding noise is that it essentially adds more data to make it harder for people to identify a specific individual if there are already very few individuals in that data set already. Now, so I've spoken about, some of the pain points, the use cases, the models that we expect to focus on, as well as our approach to privacy. I want to talk about a few use cases. So typically when we start, we always hear, hey, Tom, I can't trust the synthetic data. What do I do? Or, what can we do as a next step? Well, this is what we did here with an early client, which is we leveraged our Gen AI model with a differential privacy setting. And we trained an AI model on the real data and on 3 different synthetic data variations, one by IBM and 2 other open source. And as you can see here is first, the output is very reflective of the real data, and 2, it outperformed the other open source models. And now that drop in quality, that maybe 2.3 or 3.3%, is due to differential privacy. So the cost of being privacy protected is a small drop in accuracy, and that's due to the noise that we add. The second use case is within the telecommunication sector. And in this particular case, it was leveraging an agent-based model to tackle a what if use case. And the what if here for this company was they're thinking about exploring a new initiative where you can centralize and share information across vehicle types and vehicle vendors to hopefully reduce number of accidents on the road. And because this is new, because they had no data collected, but they were aware of the space and of the domain, they decided to create a simulation around it. They scoped down this massive problem and to, let's just first understand if we can model cars on the road and how they would behave based on what we know, speeding limits, road types, what drives traffic congestion, weather, and see if we could begin to better understand the dynamics of this new effort. Now, I just want to do two use cases. Normally, I would go through and showcase a demo, but I do have another video on that, which I'm happy to share. What I do want to do in the final couple minutes is take a look at our roadmap. So this is a new feature. Watson X is new, or we're committed to kind of not only launching this, but maturing this. And what you can see on the bottom left was our first release. So this is on watsonx.sas. We released our stats-based model. And as a reminder, if you want to do demo data, training data, internal training materials, or AI model training, this could be a good opportunity for you. Now, as we look toward the end of this year, we're going to be maturing that SaaS deployment and releasing our differential privacy, what I spoke about, as well as quality reports. And the quality reports will really help you to evaluate not only the quality of your synthetic data, but also how much privacy protection you're guaranteed in each output. Now, at the same time, we'll be launching our on-prem deployment. And so on-prem, we'll have everything that's available today on SaaS. So that's the demo data, AI model training, and training data for single table analysis in the on-prem deployment. And then looking into 2024, we'll be introducing our other models. So one, an agent-based model to handle what-if analysis, and two, our generative AI models that will help with the insight extraction, the monetization, and also help to support some of the referential integrity. And from our side, we typically deploy on SaaS first and then on-prem. So whatever you see deployed on the bottom half of this slide will then get deployed and get followed up on the on-prem version. Now, if there was something of interest, these are ways that you can engage with us and learn more. So if the stats-based model is currently available or is currently help you tackle either demo data, AI model training, or internal training data, that's available on Watson X Lite. You can start to play with that today and see if it's a good fit. I'm also happy to follow up and give you a hands-on demo before perhaps you go online. Second, you can engage in a formal POC, right? If you like the stats-based model, we're happy to engage in a POC with client engineering, and we can partner on that. The third opportunity is if there are other models that were of interest that aren't quite released or generally available, we could give you early access to some of the technology, specifically your generative AI models. We've done that with quite a few companies already at this stage, even though it won't be released till next year. It's a good opportunity to get your hands on it early, validate it, test it, so that you know what's coming and see if it can meet your needs. And let's say the stats-based model, the Gen AI early access doesn't work. We can always still partner, still have conversations. You can give us feedback to help make sure that as you continue to mature our synthetic roadmap, we take you along and you're part of the process with us. So with that said, that ends my walkthrough. I hope this has been helpful. If you have any questions at all, please route them through the sales, and then we can discuss next steps. Thanks so much.